it should also represented by the letter I. So that's why I don't like to represent the rational number by the letter I. So we are gonna represent the rational number by a letter Q and a little symbol on top to divide side of the letter Q. That's the irrational number. And what we know about the irrational number? The irrational number, they are real numbers that are not rational. So any number that is not rational is considered irrational number. The decimal notation neither terminates nor repeats. So basically, the irrational number, they have termination. The irrational number, they don't have termination. They don't terminate and they don't repeat. Because if the number repeats, that means that number is rational. Let's see some examples of the irrational number. Pi, this is a very common number, pi, in which his decimal part is 3.14, 15, 92, so on, all the way to the infinite. If you keep writing, the decimal of pi, you're never gonna see a number repeat, like a sequence, repeats. Another example of irrational number is a square root of 2, in which his decimal part is 1.41, 42, 13, 5, 6, 2, so on, all the way to the infinite. Square root of 2, again, is an irrational number because the decimal part does not repeat. Another example of irrational numbers, minus 6.12, 1, 2, 2, 1, 2, 2, 2. As you can see, this example, you see 1, 2, and then 1, 2, 2, 2 times, and then 1, 2, 2, 2, 3 times, and then obviously the next number will be 1, 2, 2, 2, 2, and so on. So this is an irrational number. Why? Because its decimal part does not repeat. You might say, yeah, but you know what? It does repeat now. It doesn't, because as you can see, it's 1, 2, it's 2, 2, it's 3, 2, it's 4, 2, then the next one will be 5, 2, the next one will be 6, 2, and so on, all the way to the infinite. That means that his decimal part does not repeat. Now that we have a little review about all the set of numbers in the real number system, we're gonna do some exercises. We're gonna do 4 of them, and then we have time, we're gonna do 2 more. So the sentence that we have is write interval notation, then graph the interval. So we have the exercise number 1, and it is written on this way: x such that minus 1 is less than or equal x, and it is less than or equal 5. So the first thing that we gotta do is write an interval notation. So basically, on the left side, you're gonna write the number on the left, minus 1, comma, and then on the right, the number on the right, which is 5, right? So we're trying to write the interval notation, first of all, right? So let's read the exercise again. X such that x minus 1 is less than or equal x. If you say is less than or equal, that means that minus 1 is included. Less than or equal. Right? So we're gonna write on the left hand side a square box, okay? Because it means it is included. And then on the right hand side, x is also less than or equal 5. We also gonna write a square, like that. because it means 5 is included, right? And then we're gonna do then graph the interval. We're gonna graph the interval. Gonna make a little graph, right? And the numbers that we have on the exercise is -1 through 5. So we have -1, 0, 1, 2, 3, 4, 5. So let's locate the numbers, right? -1 and 5. And then the exercise says that x is greater than or equal -1. Is -1 included? Yes, because it says it's greater than or equal. So we're gonna write same symbol that we write over here on the interval notation. So let's be clear. This is the interval notation and this is the graph. And then it says that x is less than or equal 5. Is 5, here we have number 5. Is 5 included? Yes or no? Yes, it is, because it says is less than or equal. So we represent it, the symbol like that. And then which numbers are greater than or equal -1 and less than or equal 5? All these numbers, right? All these numbers right here. Okay? Understood? Okay. Let's get to this example number 2. Example number 2 says x such that x is greater than -2 and is less than 2. And the first thing that we gotta do is write an interval notation. So again, in order to write the interval notation, we're gonna write the numbers that is mentioned in the exercise. On the left side we have -2, comma. On the right side we have 2, right? Okay, in this case, -2 is less than x. Let's pay attention. If -2 is less than x, that means that x is greater than -2. So all the numbers that are going to be between -2 and 2, those numbers are going to be greater than -2. So that means on the graph, they're going to be on the right hand side of -2. Let's say right here we have -2, right? So the numbers greater than -2 are going to be on the right hand side of -2. Right, let's go back to the exercise. If -2 is less than x, so that means that x is greater than -2. So the question to you is -2 included, yes or no? No, it is not, because it says that -2, x is greater than -2. It doesn't say like the previous example, it's greater than or equal. In this case, it's just greater than -2. So we are going to represent it with a parenthesis, right? To write a parenthesis, since it says that it is greater than -2. Now on the right side, let's see what it says on the other side. X is less than 2. If it's less than 2, it says that 2 is not included. So if 2 is not included, I'm going to write a parenthesis again. Now, let's do the graph. On the left side, I'm going to write, since x is greater than -2,